Welcome to another bite-sized lesson by Computer Engineering 101. Today I will be showing you how to count in binary. Let's begin with a refresher on counting the regular way. You probably learned in school that numbers are made of digits. When counting, you start with the first digit increasing from 0 up to 9. No digit can get bigger than 9, so to count higher, you reset the first digit back to 0 and add 1 to the next digit. Since a digit spills over into the next one whenever it gets to 10, we call this a base 10 number system. Binary numbers are a base 2 system, so binary numbers are made of digits which can only have two possible values, 0 or 1. To begin counting, you start with the first digit going 0, then 1, and after that we carry a 1 into the new digit and reset the first digit back to 0. Following this rule, let's see how the 1s and 0s change as we count from 1 to 10 in binary. Feel free to pause the video here and really get comfortable with how this works. Now, what if we are given a binary number and want to figure out its value? Instead of counting all the way to the number, there is an easier solution which we already use every day with our normal base 10 numbers. It may seem obvious, but let's break it down. In base 10, each digit is 10 times bigger than the next. That's how we get the ones, tens, hundreds, and thousands place. The value of each digit tells you how many ones, tens, hundreds, or thousands that you have. So let's say we have the number 2013. 2013 means that there are 2 thousands, 0 hundreds, 1 10, and 3 ones, which combined equal 2013. Now let's look at a base 2 binary number. In base 2, each digit is 2 times bigger than the last one. So we get the ones place, twos place, fours, eights, and so on. Following the same rule as before, the binary number 101 means that there are 1 fours, 0 twos, and 1 ones, which combined equal 5. So the binary number 101 equals 5. Now it's your turn. Here's a new binary number, 1011101. Don't be thrown off by the space between the 8s and 16s digit. Kind of like a comma in base 10 digits, a space is added every 4 digits in a binary number to make it easier to read. Following the process we used before, pause the video and see if you can figure out what number this binary number is equal to. All right, if you said 93, you got it. Okay, but what if we have a normal base 10 number and want to know what it looks like in binary? Start with your number, let's say 101. Next, find a digit in binary which has the closest value to 101 without going over. In our case, that's 64. Subtract 64 from 101, leaving you with 37 left over. Repeating this process, we next pick the 32's place, leaving 5 left over. Then the 4's place, which leaves 1 left over. And finally, picking the 1's place finishes it off, leaving 0 left over. So now we have a binary number, 01100101, and adding up the values of the digits we selected, we can verify that it does indeed equal to 101. Now it's your turn. Given the number 150, pause the video here and see if you can turn 150 into binary. If you said 150 equals 10010110, you got it. Now, if you have to work with binary numbers a lot, like I sometimes have to as a computer engineer, then instead of doing all that work yourself, why not have a calculator do it for you? Most computers these days have a calculator app on them with a programmer mode. In this mode, it's very easy to punch in either a normal number or a binary number and see its value in all kinds of number formats. That's it for counting in binary. Thanks for watching. I'll see you in the next lesson of Computer Engineering 101.